Hello, scientists. It is March 10th, Diletta's birthday. And for science today, what? Are you noticing I have something stuck to my shirt or something? I don't know what you're talking about. What? This whole thing? Oh, it just travels around with me, up here or down there and like whatever. It's no big deal. Oh, now it's on my face. I mean, no big deal. So, today, for science, you're going to learn about, you guessed it, static electricity. Woohoo! Have you ever... Oh, now it's stuck to my throat. That's okay. Have you ever shocked somebody? Your feet go across the floor and then you touch somebody and they go, ouch! And they get shocked? Yeah. Have you ever had a balloon just growing out of your neck? Yeah, I do. Have you ever played with balloons before where your hair goes really high up into the sky? I think I have too much hairspray in mine. I don't think mine will do it. If you have a balloon at home, it'd be really fun if you could blow that up and do this experiment with me today. Just for fun, just blow it up, and then actually you're going to use this experiment tomorrow. Today you're learning about this. Today you're learning about static electricity. And so you're going to be thinking first before, of course, because scientists think and predict first. You're going to think and predict, why did this balloon that I rubbed on my shirt now just stick? Why did this balloon I rubbed on my shirt now stick to here? I didn't put any tape on it or anything. So why are these sticking? Think like a scientist. Why are these sticking? Think about what we've learned so far about magnets and the magnetic field, and put a prediction on slide 2. It'll say, have you ever rubbed a balloon on your head or stuck it to a wall? Even if you haven't, I just did, so you could watch that. And have you ever gotten to school and then see pet hair on your clothing? My cat, always. I have her fur. But why does it stick? Why do these things happen? Why does that fur stick? Or why does this balloon stick on the wall? Write your predictions. Then you can learn about it. So as scientists, we need to predict first. So predict, pause, and predict. Then let's read together about electric force. We have electricity all around us we don't even know. Let's learn. We have learned that some forces require contact and some forces do not. Non-contact, so not touching, forces are invisible forces that create a push or a pull without actually touching. That's the gravitational, or the magnetic field, the magnetic field. Gravitational, magnetic, and electrical are all examples of non-contact forces. An electrical force occurs because all objects have a charge, either positive or negative. Okay, they have some kind of charge, positive or negative, north, south pole, positive, negative. They have a charge. Just like if you look at a battery, I'll show you in a second. Just like magnetic poles, electrical charges are either positive or negative. Thinking about our learning of how magnetic forces work, what do you think will happen when a positive and negative charge interact? When positive and negative charges interact. If you ever look at a battery, one side says A side and one side, or a plus sign, and the other side has a minus sign. So a negative and a positive. That's what we're talking about today. Electricity and magnets are part of the same force called electromagnetism. Electromagnetism, you say it. You are surrounded by electromagnets all the time. They are used in speakers, microphones, headphones, doorbells, and much more. Electric and magnetic forces work the same way. Identical charges, meaning the same as, charges repel. So like a positive, or a north and a north, or a south and a south, those will push away from each other. They'll repel. And opposite charges attract. So a north pole, south pole, positive, negative, those attract. When you rub the balloon on your head or sweater, you are giving it a negative charge. The wall has positive charges. So when you place the balloon next to the wall, the positive charges attract and the negative attract the negative charges, and the balloon sticks to the wall. Isn't that cool? There's a really cool video I want you to stop and watch about this. And she is able to, with her technology and the tools that she has, be able to explain that in really, really great way, better than I could. So I want you to watch her about static electricity. Then, finally, when you're done watching the video and reading the reading materials with me today, I want you to move over. So use your knowledge of what you know so far about electrical forces to decide if these statements are true or false. So you're going to drag and drop. Electrical forces are known as a non-contact force. I remember non-contact, but let's go back up and look. So electrical forces are used as a non-contact. I remember reading about that up here. Let's see. Non-contact forces are invisible forces that create a push or pull without actually touching. Gravitational, magnetic, and electrical are all examples of non-contact forces. So electrical forces are known as non-contact force. What did it say? Yes. See, it's right there in the reading. We just have to go back. Opposite charges repel. So as you may remember, this is like opposites attract. Electrical forces have positive and negative charges. Electrical forces have positive and negative charges. Let's find out. So, electrical forces, whoops, I think I need to go up here. Electrical force occurs because all objects have a charge, either positive or negative. Okay, they have a charge of either positive or negative. Okay. So just like magnetic poles, electrical charges are either positive or negative. Okay, so they're not both. Okay, all right, and then electric forces are not like magnetic forces. Electric forces are not like magnetic. Electricity and magnets are part of the same force. Oh, I think we just read that. True or false on that one? Electric force requires contact. Does an electric force require contact? Look at right here. Electric and magnetic forces work the same way. Identical charges repel and opposite charges attract. When you rub the balloon, okay, so do you have to have contact to make them work? Oh, it's right there. Might want to reread that page. And then positive and negative charges attract. I think we said that a couple times. So there should be about 3 for each one. Okay. Use your knowledge of the forces to be able to drop. And that is all you're doing today. Okay, my scientists, I hope you enjoyed learning about static electricity. This is our last lesson of this unit, and starting next week, we will start back on Michigan history. Thanks, scientists, and have a great day. Bye-bye.